हेलो चिल्ड्रन। आज हम लोग डिस्कशन स्टार्ट करेंगे हेडिंग नंबर 10.6 पॉलीहैलोजन कंपाउंड्स. So as the name indicating, the compounds which are containing more than one halogen atom in their molecules are known as polyhalogen compounds. Few examples are given here as dichloromethane, dichloroethane. Okay, so these carbon 1 and 2, so 1 2 dichloroethane. Okay children, then this is 1 1 dichloroethane because both the chlorine atoms are present with same carbon, so 1 1 dichloroethane. Chloroform CHCl3 trichloromethane. Okay children, so the most common use of these polyhalogen compounds is these all are used as a solvent. Okay, so one most common use of all the different type of polyhalogen compounds is that these are used as a solvent. So the first polyhalogen compound which is in your syllabus is chloroform, which is also known as trichloromethane. So IUPAC name of chloroform is trichloromethane. The molecular formula is CHCl3. Okay children, so according to this molecular formula, 3 hydrogen atoms of methane get displaced by 3 chlorine atoms in chloroform. Okay, so preparation. First, the most common preparation which is also a industrial preparation of chloroform, and this is by the chlorination of methane. So methane, when reacts with chlorine in the presence of sunlight, one by one 3 hydrogen atoms of methane get displaced by chlorine atoms, and due to this we will get chloroform. Okay, so this reaction is taking place through free radical chain mechanism reaction, free radical substitution chain mechanism reaction. Okay, so due to this chain mechanism, all the possible halogen derivatives are formed here in this reaction. Okay, so out of different type of chloromethane, the first chloromethane, monochloromethane, dichloromethane, trichloromethane, which is chloroform, and the last compound is tetrachloromethane, also known as carbon tetrachloride. So this is the industrial preparation. The next, the preparation which is in your syllabus is laboratory method, and in a laboratory method, chloroform is prepared by bleaching powder and ethyl or acetone, ethyl alcohol or acetone, and you can use chlorine and sodium hydroxide with ethyl alcohol or acetone. Okay children, so these are the reagent for the laboratory preparation of chloroform, in which you can react bleaching powder with ethyl alcohol or acetone, or in second way you can prepare chloroform with chlorine, sodium hydroxide and ethyl alcohol or acetone. Okay children, so only preparation reactions are in your syllabus. So reactions of the preparation, so it is a little bit complicated reaction and its exact mechanism is not clear, but we can represent this whole conversion in the form of different steps. So the first preparation, formation of chloroform from ethyl alcohol. and bleaching powder. Okay, so bleaching powder and ethyl alcohol when react form chloroform. So according to the first step of this conversion, bleaching powder reacts with water forming calcium hydroxide and chlorine. So bleaching powder is acting as substance which is producing chlorine, and further reaction of ethyl alcohol is with this chlorine only. Okay children, so this chlorine which is formed here will behave or will react in two different ways with ethyl alcohol. Okay, so this chlorine will behave as chlorinating agent and also as oxidizing agent. So two different function will be performed by this chlorine with ethyl alcohol. So this chlorine with moisture or water will form HCl and nascent oxygen. So this nascent oxygen will oxidize ethyl alcohol in the form of ethanol. Okay children, so in this conversion this chlorine is acting as oxidizing agent. This chlorine oxidizes ethyl alcohol in the form of ethanol. Okay, so first chlorine is producing nascent oxygen or atomic oxygen, which is further used for the oxidation of ethanol to ethanol. Third step, here the chlorine is acting as chlorinating agent. So this chlorine which is produced here is reacting with ethanol produced here in B step, and reaction of chlorine with ethanol, formation of trichloroethanol, which is also known as chloral. Okay, so from ethanol chloral will form, and at last this chloral will react with calcium hydroxide, chloral with calcium hydroxide, and this calcium hydroxide is formed in step A here, where bleaching powder is reacting with water. Okay, so this calcium hydroxide in D step is reacting with chloral, forming chloroform and calcium formate as byproduct. Okay children, so this is overall conversion of ethanol in chloroform with bleaching powder. So we can summarize these all steps once again. In first step, bleaching powder is get converted in the form of calcium hydroxide and chlorine. So overall, bleaching powder reacting with water forming calcium hydroxide and chlorine, and this chlorine will act in two different ways, as a chlorinating agent for ethanol and also as an oxidizing agent for ethanol. Okay children, so this chlorine will react with water, form a nascent oxygen, and this nascent oxygen will oxidize ethanol to ethanol. Then in next step, ethanol with chlorine will form chloral, and this chloral will react with calcium hydroxide, which is formed in step A, and formation of chloroform and calcium formate is taking place. Okay children, so this is overall formation of chloroform from ethyl alcohol. The next formation reaction is formation of chloroform from acetone. Okay children, acetone. So here in A step, bleaching powder is converted in the form of calcium hydroxide and chlorine. Then this chlorine which is formed here is acting as chlorinating agent. Okay, so chlorine with acetone will form trichloroacetone. Okay children, trichloroacetone. Then in step C, this trichloroacetone is reacting with calcium hydroxide, chloroform, and calcium acetate is formed here. Okay children, so what is the difference in these two preparation reactions actually? So as you can see that here in this step, in this reaction where acetone is taking part for the formation of chloroform, chlorine is acting only as chlorinating agent. Okay, not as oxidizing agent. It is acting only as chlorinating agent. Okay, so for the formation of chloroform, we can use ethanol or ethanol or acetone. Ethanol or acetone. Okay, when we are using ethanol, then chlorine is performing two different functions, as a chlorinating agent and also as a oxidizing agent. But when we are using ethanol or acetone, then chlorine has to perform only chlorinating agent, as a chlorinating agent only. Okay children, then next is physical properties of chloroform. Colorless, heavy liquid, having sickly sweet smell, and taste. Boiling point is 334 Kelvin. Okay, so it is a sweet smell liquid and colorless, heavy liquid. Then chemical properties of chloroform. Chemical properties. So first is oxidation of chloroform. Chloroform in the presence of light and air oxidized in the form of a poisonous gas which is known as phosgene. Phosgene. So in the presence of sunlight and air, chloroform get oxidized in the form of phosgene gas, which is a highly poisonous gas. Okay, so to prevent the oxidation of chloroform, what we have to do, we have to take number of precautions for this. And according to the first precaution, chloroform is always kept in dark colored bottles. Why? To cut off light from the chloroform. Okay, the second point, bottles are filled up to the brim to exclude air. And third, which is very important point, small quantity of ethanol is added, and for this purpose we use about 1% ethanol solution in chloroform. So ethanol acts as negative catalyst and decreases the oxidation of chloroform. Okay, so oxidation reaction of chloroform in the form of phosgene will get suppressed by ethanol, and also it reacts with phosgene formed and converts it into non-toxic diethyl carbonate. Okay, so there are two functions of ethanol in chloroform. It is behaving as a negative catalyst, and also it is converting phosgene in the form of diethyl carbonate, which is a non-toxic substance. The next is hydrolysis of chloroform. So when chloroform reacts with alcoholic NaOH, it first forms trihydroxymethane, which is a unstable compound. Okay, and this trihydroxymethane get converted in the form of formic acid after removing one molecule of water. Okay, and finally sodium formate as a product is formed. Okay children, so with sodium hydroxide, on hydrolysis, chloroform is first converted in the form of trihydroxymethane, which is an unstable compound, because you know that at one carbon, two hydroxide group cannot exist together. Okay children, because these groups are, hydroxy groups are a bulky group and their electron cloud are overlapping each other here. Okay, so these overlapping of electron cloud will make the presence of two hydroxy group with the same carbon very difficult. Okay, and in the case of this trihydroxymethane, this condition is hardest one. Okay, so from this unstable compound, a molecule of water will be removed, and then this compound will be converted in the form of formic acid, and this formic acid at last, due to the presence of sodium hydroxide, will convert it in the form of sodium formate. Okay, next is nitration. So under nitration reaction, chloropicrin is formed as a product, chloropicrin, and this chloropicrin is an insecticide and also used as a war gas. Okay, so chloropicrin chemical name is nitrochloroform. Okay, so in chloropicrin, the one hydrogen atom of the chloroform get displaced by nitro group. Chloropicrin is formed, which is used as an insecticide and as a war gas. The next reaction with acetone. So it is a addition reaction type of reaction in which one molecule of acetone is added with one molecule of chloroform. So due to this reaction, chloritone is formed as product, chloritone. Okay, this is chloritone. So acetone is reacting with chloroform and chloritone is formed as a product. This chloritone is used as hypotic substance. Okay, and this hypotic term is taken from a Greek word hypnos, which means sleep. Okay, so these substance, this chloritone is a substance which is used as a sleeping substance or in sleeping pills. Okay children, chloritone. The next property of chloroform with silver powder. Important property, silver powder. And when chloroform is react with silver, acetylene is formed as a product, acetylene. Okay, so chloroform, two molecules, silver, acetylene is formed, or ethyne. Then Carbil amine reaction, very important name reaction, Carbil amine reaction. Okay, so in this reaction, chloroform reacts with primary aromatic or aliphatic amine, primary aromatic or aliphatic amines. Okay children, so this amine can be of aromatic or aliphatic type. So when this amine react with chloroform and KOH, okay, so alkyl isocyanide is formed. Alkyl isocyanide is formed as product. Okay children, alkyl isocyanide is formed. This alkyl isocyanide is a bad smelling substance, and this reaction is used in a number of ways. Okay, the first way for the testing of aromatic and aliphatic primary amines. Okay, second as the preparation reaction of isocyanide, and third, this reaction can also be used as a test reaction for chloroform. Okay children, so in this reaction, primary aromatic or aliphatic amines react with chloroform and KOH. Related isocyanide is formed. Isocyanide, which is a foul smelling or bad smelling substance, and the formation of this bad smelling substance is proved that amine is present. Primary aromatic or aliphatic amine is present. Okay, this reaction is not given by secondary and tertiary amines. Then Riemer-Tiemann reaction, very important reaction. So when chloroform is react with phenol in the presence of KOH under 33 Kelvin temperature, so salicylaldehyde is formed. Salicylaldehyde, or you can say 2-hydroxybenzaldehyde. 2-hydroxybenzaldehyde is formed as a product. Okay, so the formation of salicylaldehyde from phenol and chloroform is Riemer-Tiemann reaction. Okay children, use of chloroform, as I told you that all the polyhalogens can be used as solvent. Then chloroform is also used for the testing of primary amines, used as solvent, as a preservative. Okay children, and it is also used as anesthetic in surgery. Thank you.